Hi guys, welcome to another iOS tutorial from Confidence Labs, and in this tutorial we will be learning how we can implement generic multi-delegate pattern in iOS. Before starting its implementation, we must be familiar with two of iOS well-known design patterns. First one is delegate pattern and second one is observer pattern. So delegate pattern is used for one-to-one communication in which one object tries to notify a delegate object regarding an event. An observer pattern is used for one-to-many communication in which one object publishes an event and all its observer tries to listen to that event and react accordingly. So in this generic multi-delegate pattern, we will be using well-known delegate pattern to implement one-to-many communication. So remember, the normal delegate pattern is used for one-to-one communication, and this generic multi-delegate pattern will be used for one-to-many communication. While learning that, we will also learn few other things like thread safety and how memory management works with arrays. So before starting the implementation, I'll try to give you an example or a scenario in which this generic multi-delegate pattern can be used. Suppose if you're creating a chat-based application or a messaging service app, in that case, your app will be notified whenever it receives a new message from anyone. So suppose for that you have an event called application did received message. So that's a single event which needs to be notified to multiple objects. So who are these multiple objects? So let's take an example. I just googled a chat application and I got these screenshot. So we will try to find out those objects who needs to be identified whenever a new message is received. So that's an event, and that event has to be notified to this tab bar so that this icon can show a badge that you have one unread messages or whatever would be the number of unread messages. Whenever a new message has arrived, that badge has need to be updated. So this tab bar need to be notified whenever a new message has been arrived. Similarly, this table view has to be notified whenever a new message has arrived, so that this chat table view can be updated with the new message. Similarly, a particular chat screen also has to be notified whenever a new message has arrived. Suppose this message, the new message belong to this chat, then this collection view also needs to be updated. So this is a perfect scenario where you can use the generic multi-delegate pattern because there is a single event uh, and which needs to be notified to multiple objects. So now we have understood what generic multi-delegate pattern is, and what is what are the kind of scenarios where we can use this generic multi-delegate pattern. So let's start implementing it. So we will be using playground to implement that multi-delegate pattern. So before starting implementing it, we will try to replicate the scenario of chat application. For that I'll create a class which represents the chat screen. Now I'll create a class which will represent tab bar. So I'm not actually creating a chat application because our focus is on to demonstrate how we can implement multi-delegate pattern. If I'll start implementing the chat application from scratch, then it will be a complete waste of time because our focus is on multi-delegate pattern, not on chat based application, right? So that's why I'm using playground and simulating the chat screen and tab bar with this fake classes, you can say. So let's continue. Now we will create a protocol message delegate. We will create a class message. So this is a model class for message. This class, the object of this class will represent the message. It can in real app it can have objects like sender id, receiver id and all. Oh, let's write the delegate function here. Did received message, and here, or what we can do is here message. So this will be our delegate function. Let these screens implement this delegate message. Maybe this has to be defined before the implementation of the class. Message delegate, and the tab bar will also confirm this message delegate, and now they have to implement the function did received. Similar is the case here on tab bar. So here chat screen can update its collection view whenever a new message has arrived, if that message belongs to that chat, and tab bar can update its unread icon count, icon batch count. So now our setup is done. Now we will focus on creating the multi delegate. So let's create the class multi. For now I'm not creating it generic, I'll do that later in this tutorial. We'll create an array of delegates which will hold all the delegates. So for now we are defining its type as message delegate that we just created. We'll write a function to add delegate, delegate message delegate. Now we'll write a function to remove delegate, let's actually add and delete delegates inside this function. So for adding we will simply do that, adding the delegate object passed in add function to the delegates array that we have. So now I will implement the invoke function. Invoke function will take a message and it will tell all the delegates that it has received a new message. So all the delegates will be inside delegates array, and to iterate over each element of that array I'll use the for each, and to each delegate we will notify them via this did received function and will pass the message. So all the delegates who registered themselves using add function and added themselves in this delegates array will be notified when the invoke function will be invoked, and the did received message function will be invoked for each and every delegate like chat screen and tab bar. Now let's we can test our implementation, though we have to work a lot on it, but still let's test our basic implementation. Message delegate, let's create the object of multi delegate. Now let's create the object for chat screen. Oh man, chat screen dot innate. Similarly, let's create the object for tab bar dot innate, and now we'll register both of these objects as a delegate of this message delegate dot add chat screen tab bar. We'll do a little change as well. We'll add a text property inside this message, and we'll initialize it with text, so that self dot text is equal to text. Now how do we get to know that this function has been executed? So for that we will write a print statement here. So first we will print the type of the current object, so that we will know that did received is executed for chat screen or tab bar. Then after that we will print the text of the message. Similarly we will copy it and we will paste it here. Now we will create a message. Let's create a message is equal to message dot init with text. Let's say hi as the text, and finally we will call the invoke function and will pass the message here. So when this invoke function will be called, this message will be passed to each and every delegates which has registered itself using this add function. Like here, chat screen and tab bar has registered itself as a delegate to this message delegate using this add function. When we have invoked this function called invoke, all the delegates will be notified via this function did received message, and so one by one this did received will be invoked for chat screen and tab bar as they have registered itself as a delegate, and this print statement will be executed. So looks good. So let's run it and see if those two delegate functions will be invoked or not. Yeah, you can see one by one. So first it this function is invoked. First it has print the type of the cell, which is chat screen, and then the message, the text of the message, which is hi. Similarly the type of the cell, which is tab bar, and the text of the message, which is hi. Now let's go to the next step. So suppose the in message delegate we will add another function which is did delete message. So these days in chat application you can also delete a message, right? So whenever someone has deleted a message, this function will be invoked. Fix. Okay, so how do we notify if someone has deleted a message using did delete from our multi delegate? Do we need to create another invoke function separately for did delete? No, because that doesn't make sense. So in this case, if there will be like uh, 15-20 delegate messages, we won't be creating 15 or 20 invoke functions inside our multi delegate. So for that what we will do is, uh, instead of calling this did receive directly, we will accept a closure here, closure, in which we will pass the object of message delegate, and it will return nothing, and the one who invoked this invoke function will decide which event needs to be called. So instead of this, we'll invoke this closure and pass each of the delegate with that closure. So now on message delegate I will call invoke, and here the closure will get the delegate one by one, and inside this closure the caller can choose which event needs to be fired. So from here he can invoke the did receive message, or in case of a deletion of message, the caller can invoke did delete message. So this has made our multi-delegate a little bit more flexible. We can add any number of functions in our delegate, and the caller of invoke function can decide which event has to be fired. So now suppose there's another protocol in our application, chat based application, which also needs one to many communication. So let's create a hypothetical protocol, maybe friend request, maybe friends delegate. uh, usually chat based application doesn't have friend request concept, but still we are taking a hypothetical scenario, and this delegate will tell if the application has received any friend request, or if you're or it can have multiple functions, just a hypothetical scenario. So now this delegate also needs to have one to many communication, but our multi delegate only supports this message delegate. So in that case, do we need to create another multi delegate separately for this friends delegate to achieve one to many communication? No. So ideally our multi delegate should be generic, so let's make it generic. So multi-delegate class will be binded with a type T. It could be any type. It will be defined when we will be creating the object of multi-delegate. So now the delegate could be of any type, and here as well. So we have removed the specific multi-delegate from everywhere. Okay, so now here while creating a multi-delegate I need to pass a type that this multi-delegate would support. So here I'll pass the message delegate, because this multi-delegate is for message delegates. Now the T would in that case, in this object the T would be replaced by this message delegate. This is because of the concept of generics. We have used the concept of generics here, which is a very powerful concept. And now I can create a friends delegate object as well. Multi delegate, and I'll pass friends delegate as the generic parameter. And now if chat screen will accept friend delegate as well, first I need to implement the function. Looks fine now. And now I can add chat screen as a delegate of this friends delegate. I can also add multiple other delegates who want to listen to the events of this friends delegate, and we can invoke the invoke function, and here we can invoke our did receive request function. So now we have made our multi-delegate class a generic class, and any protocol which needs to have one-to-many communication can use this multi-delegate class. So everything looks good now, but that's not the case. We have a bug here, and to show that I will implement the innate initializer of chat screen here, and I'll print a statement here so that we can identify the initializer of chat screen has been executed. We'll also print the function name here. Let's copy this. We'll also implement the de-initializer here so that we can know when the object of chat screen has been deallocated by our operating system. Let's delete it for now, and yeah, so the object of chat screen has been created here. So when this line will be executed, the initializer will be executed, and we can see a print statement. Okay, and suppose if I make chat screen nil here, then the d init must be executed, and this print statement must be executed, and we should see this print statement in the console. A little date chat screen. So let's run it and see. So you can see the initializer is executed. We can see the print statement, the type it's chat screen, and the function is init. So we can see when the object of this chat screen has created, the initializer is executed, but when we assign nil to that object, chat screen object, it should be deallocated and the deinitializer must be executed, but that's not happening. Why? Because our array, because we have added the chat screen inside the delegates array using this add function. So the object of chat screen is also inside this delegates array. So its reference count is 2, and when we have make it nil, its reference count is decreased by 1, and it still have a reference count of 1. That's why it's not deallocated by our operating system. So the point here is that array holds its element strongly. So in this case, what we want to do is we want to hold all the delegates weakly, because if we will hold all the delegates strongly, then in case of chat screen, suppose the when the chat screen is presented and it has registered itself as a delegate, now it has been dismissed, and it's still inside this delegates array, it's still in the object of the chat screen still exists inside that delegates array, then it will be notified whenever any new message has been received. So this uh, this did received function will be executed for that object, and inside that it will try to update the collection view, but collection view would have been gone already. The collection view would be nil because the chat screen has been already dismissed. The object has not been deallocated because of the strong references maintained by the array. So in that case your app will crash. So that's why we want our array to hold all the delegates weakly. By default, array hold its elements strongly, all the reference type elements strongly. So there are two ways we can do it. First thing is we can use the ns pointer array, it holds its objects weakly. But that's what not I'm gonna do here. I'll create a class. I'll name it weak for now. I'll create a weak variable inside it, value, which will be the type of any object. Weak are always optional. Innate with value any object, self dot value equals to value. And it will also confirm equitable protocol. Equitable protocol, if a class confirms to equitable protocol, then we can use this double equal to operator to equate two objects of the same type. So we will implement it. We will return LHS dot value we will use triple equal to here, because triple equal to compare the value and the type as well. And now instead of this t, we will have the array of type weak. And now we will update our implementation as well, because first we will typecast this delegate into weak. And now we'll pass this inside our delegates array. And before passing it, we can even check if it already exists by doing delegates dot contains this. So if the delegate is already registered, then this check will remove the duplicacy. So it will be only added to delegates array if it's not registered before. So looks good to me. Now while invoking as well, because now delegates array has the elements of type weak, first we need to we can use the guard statement here. Guard let value equals to $0, which will be representing an element of type weak. So value as t, else return, otherwise call this closure with the value. So in this case, suppose uh, we can take the example of our chat screen that we discussed earlier. Suppose if the chat screen is already dismissed, so the object of the chat screen which has been added in the delegates would become nil. And so that's why we are checking the value. If it's nil, then return. Don't call the closure for nil value, otherwise call the closure for with the value if you got the value inside delegates array. And on the value of that delegate, the desired function, desired event would be executed. Let's move to the remove part. Let's also implement this remove function. It's very simple. Delegates dot remove all sorry, $0 equals to, oh, that week is equals to, so this will remove the desired delegate from the delegates array, and everything looks good. So now our delegates array refer to all the delegates weekly. So now in this case, when we have made our chat screen nil, or hypothetically if a chat screen is dismissed, ideally it should invoke the de-initializer now. So let's run it and test it. Yes, you can see now the de-initializer is also invoked. So because the delegates array is holding the all the delegate weekly, so when the chat screen object has been passed to this message delegate, the reference count of this chat screen won't increase, it will remain 1. And when this chat screen property assigned with nil, it will be decreased by 1, it will become 0, and our uh, operating system will de-initialize the object of this chat screen, and this de-init will execute, and you can see the print statement below. So our multi-delegate is ready, our generic multi-delegate is ready, but still we can do some changes to make it perfect. So first change we will do is we can replace this for each with filter, so that we can filter all those delegates which have become nil now. So let's do it. We will replace it with filter, and in case the value has become nil, we will return here false, so that it will be filtered, that particular delegate will be filtered. And in case the value we got the value, then we can return true here, so that that delegate will remain in the filtered delegates array. And another improvement that we can do here is we can make it thread safe, so that addition and deletion of delegates can be done from different threads, and still the data inside the multi-delegate would be consistent. So let's do it. Queue, let's create a queue, dispatch queue. By default the queue we create is a serial queue, and we will give it a label, multi-delegate. Make sure that the label you give must be unique, it shouldn't be used in your application elsewhere. And now we will put all the execution inside the synchronous block. Cut the code, put it inside your synchronous block. Again, queue dot sync, put it inside the synchronous block. Similarly, queue dot sync, put it inside the synchronous block. So this synchronous block will make sure that even if those functions are called from different threads, but still they will execute synchronously. So we are done with our generic multi-delegate pattern. One thing we can quickly do it is, whenever I create some pattern or anything, I used to create a framework for that, so that I can reuse that framework in any of my application. So let's quickly go to file, go to new. I'll show you how you can create a framework quickly. Framework, next, let's name it multi delegate. Everything's look good. Let's do this. Yeah, let's go next, create. So the framework is created. Let's quickly create a class here. New file. Let's name it Multi Delegate. Good. Let's create another class here. Name it week. Looks good. Let's go back here. Copy this. And paste it inside multi-delegate. And again, let's go here and copy the week class. And paste it here. So the week class has to be internal, but this multi-delegate has to be public, and the functions inside it also needs to be public. This one also, and both of them needs to be private. So our framework is ready, and one thing I forgot here is this one. I should update the delegates array after filtering it. Looks good. Now let's try to use this multi-delegate framework in real life application. So this is my application, and this is our multi-delegate framework. What I'll do is I'll simply drag it here. Done. And now I will select the target here, go to the general, and I will add it my multi-delegate framework here. And let's go to any class. Let's import multi-delegate. Let's build, otherwise it will keep on giving me error. Oh, it's compiling for iOS 13. Let's check what's the issue here. Okay, let's make it 13.0. Yeah, let's build it now. Yeah, build is succeeded. Now I'll show we can use it here. Let's try to create a protocol XYZ. Let's not have any function inside it, and let multi delegate is equals to multi delegate dot we can pass the protocol here XYZ. Now we can, okay, we forgot to do something. So we need to make the initializer for this one public. Let's build it again. Yes, build, done. Let's go here, and now, yeah, now it's fine, and now we can call add and invoke as usual. So So that's it for now. I hope you have learned a lot in this tutorial, and I'll keep coming back with such tutorials. My upcoming tutorial would be one on event bus pattern, and next one would be on dependency container. Both are very advanced topic and useful ones. So that's it